Once again, let me take this opportunity to welcome back to this channel, my people. This is our third lesson that we are going to continue on the formation of quadratic equation on book 3. And with me here, I have a case, that scenario that we are going to have so that you can be able to drive a quadratic equation out of this. So in this, I have an equation which says that Peter travels to his uncle's home 30 kilometers away from his place. He cycles for 2/3 of the journey before the bicycle develops mechanical problem and he has to push it for the rest of the journey. If this cycling speed is 10 kilometers per hour faster than his walking speed and he completes the journey in 3 hours 20 minutes, determine his cycling speed. So let me take my highlighter here so that we can be able to proceed from there. So the first thing, we know that maybe speed is equals to distance or over time, and then maybe we can also say distance is equal to speed multiplied by time, all that kind of things. So let me have this. So for the first thing, we are going to get the time it takes in cycling. And we are told Peter travels to his uncle 30 kilometers away from his place. So the distance is 30 kilometers. And he cycles the 2/3 of the journey. So let us see the time taken for him to cycle. And first of all, we need to get the distance he cycled. D, maybe, dist, maybe cycled. This one will be given by, it is 2/3, so it is 2 divided by 3, that is 2/3, then we multiplied by 30. And in this case, this one is going to give us 20 kilometers. So 20 kilometers is the distance that he traveled. Maybe assuming that he had the speed of, we take the speed to be, here to be x. So meaning that the time of cycling will be given by distance all over the speed, which is 20 divided by x. So that is the time that Peter cycled. And then we can also get the time he walked. Remember, the remaining distance we need first of all to get the remaining distance. And the remaining distance, since he had cycled for 20, was 30 minus 20, which gives us 10 kilometers. So that was the distance that he had walked. So for us to be able to get the time taken in walking, we need to get the time taken in walking. And here we are told that if the cycling speed is 10 kilometers faster, meaning that if he had the speed of x in cycling and this one is 10 faster, so the speed for walking will be given by x, then we minus 10 kilometers per hour. So to get the time he used to walk is going to be the distance, which is 10 kilometers, divided by speed, which is x minus 10, which is x minus 10, which is x minus 10. So now, for me to get the total time he took, that is the total time he cycled and also the total time he walked, I'm going to say, so here, now I'm going to have this, and in this case, I will have this one being, the total time we have been told it is that, so we can have this one being the time for cycling, which is 20 divided by x, then plus the time for walking, which is 10 divided by x minus 10, and then this one is the same as 10 out of 3 is the same as 10 out of 3. So now from there we can be able to compare this. We can be able to compare this so that we have maybe the first one, which is the LCM or whatever, so that we can see what it is going to give us, what it is going to give us. So in this case, the LCM here is what? The LCM is x squared all over that. So here we are going to be left with, if we expand this, we can get this one to be around maybe, for example, 16. Then x minus 10, then plus 30, then this is x, and then all these is equals to, on the other side it will be 10, then we have x, and then we have x minus 10, like that. So when we expand all these, we are supposed to arrive at 10 x squared, then minus 190 x, and then plus 600 is equals to 0. So we can simplify this by dividing by 10, so that we can be left with this one being x squared, then minus 19x, and then this one is plus 60 is equals to 0. Then we can solve that with one of the formula that we had yesterday. I think the easiest formula to solve is the quadratic formula, so which we have this one being x is equals to, our b is equals to 19, a negative and a negative will give a positive, then plus or minus the square root of 19. In this question, we are told that a positive 2-digit number is such that the product of the digit is 24. When the digits are reversed, the number formed is greater than the original number by 18. Then we are told to find the number. So in this case, what we are going to do, we can have the two numbers that we think two positive 2-digit numbers such that the product is 24. So any number here, in this case, we can have the number being maybe x, y, and we are told that when they are multiplied, this one gives us a 24. It gives us a 24. And when the digits are reversed, the number formed is greater than the original number by 18. When the numbers are reversed is greater than 18. So meaning that when we are going to reverse them, if we reverse them, we are going to have maybe the number that we are going to reverse, that is we have it being now y x. That is what it means by reversing. So now if we subtract the first and the second, we are supposed to get, and remember we can write the total value of this to be maybe 10 y then plus x. This is just the same, like maybe we have a number like 13, we can also write it as 10 plus 3 and still arrive at 10. Remember the place value of 1 is tens. And then the other one, we can have it being minus. Here we have 10x then plus y, 10x plus y. So now we are told that when we reverse those two numbers, we are supposed to get what? 18. We are supposed to get 18. So we can say that here we have 10y then plus x, then here we have minus there, then we have 10x, then a minus and 10x then minus also we are going to have 10x minus y on the other side. So if we correct the right terms here, we are going to have 9y, then minus 9x is equals to 18. Then we can divide all through by 9, so that we have this being y minus x is equals to 2, and then we can call that one our equation 2. We can call that one our equation 2. So now we can come with our formula and try to substitute here. We can have the value of y being here. We can say that y will be equivalent to 2 then plus x, and then in our first equation we can come substituting that. So we are going to have x then multiplied by 2 then plus x like that, and then this one is equals to 24, like that. Then we can open the brackets there, so we shall have x squared then minus 2x, then we bring that on this side, so we have 24 is equals to 0, and then from there we can solve it using the completing square method. And if we solve this one using the completing square method, we are going to have our x being equivalent to here, so this one is plus, equivalent to negative 2, then plus or minus the square root of 2 squared is 4, then minus